we have less than 1 minute left for today's puzzle. Hey, Sir Chowtik. Good morning. You've been sent by Tim Serapen to check out the stream today. Well, that might mean that you are from Belgium or around. So, if that's so, good morning to you too. What time zone are you in? And in the meantime, I'm going to set myself up for day 9. I need to make a Python file because I'm working in Python. And day 9. And normally I would do this a day in advance, but yeah, yesterday we went to bed a little bit earlier, so we can have a good rest. And what I like to do is have a class. Oh, we're actually counting down already. Hey, Willem, good old friend. Thanks for joining. Cool, and that you woke up so early also. So let's see about today's puzzle. It's already starting. Sensor boost. And by the way, Willem, I know that you also do Advent of Code, and I think you've solved all of the puzzles so far. We have a leaderboard. It's up there. You can be on this leaderboard. What you need to do is just use this join code, and I will make sure that you're on the list with your Twitch name also. Day 9, sensor boost. You've just said goodbye to the rebooted rover and left Mars when you received a faint distress signal coming from the asteroid belt. You're welcome. It must be the Ceres monitoring station. In order to lock onto the signal, you'll need to boost your sensors. The elves sent up the latest boost program. That sounds a little bit like the amplifier puzzle we had a few days before. The basic operation of system test. And I'm not reading the wrong puzzle, am I? No, it's really day 9. All right. While boost is capable of boosting your sensors, the puzzle input, for tenuous safety reasons, it refuses to do so until the computer it runs on passes some checks to demonstrate it's a complete IntCode computer. Your existing IntCode computer is missing one key feature. It needs support for parameters in relative mode. Okay. Parameters in mode 2, relative mode, behave very similar to parameters in position mode. The parameter is interpreted as a position. Like position mode, parameters in relative mode can be read from or written to. The important difference is that relative mode parameters don't count from the address 0, instead they count from a value called the relative base. The relative base starts at 0. The address a relative mode parameter refers to is itself plus the current relative base. The address a relative mode parameter refers to is itself plus the current relative base. Okay. That's going to require a little bit of refactoring. I think I probably have made already too many abstractions that I need to break through now. We'll see. When the relative base is 0, a relative mode parameters and position mode parameters with the same value refer to the same address. That makes sense. Because absolute means relative to 0, right? For example, given a relative base of 50, okay, that makes sense. We have negative relative mode also. The relative base is modified with the relative base offset instruction. Okay. Oh, okay. You have to modify it explicitly. Opcode 9 adjusts the relative base by the value of its only parameter. Okay. So I think I had just a moment ago, I had 2 ways of interpreting that, and I'm going to just write down my interpretation and make sure that I get it right. So we have our program, which is kind of like a list of instructions. We have a relative base that starts at 0, and of course we have our instruction pointer that also starts at 0. And there's a certain opcode that adjusts the relative base by the value of its only parameter. So it increases it or decreases it. So there is a certain opcode, it's 9, and it is called adjust relative base, and it would move the relative base to the right or to the left. But there was another part that said the relative base is itself, something like that. Let's see where that was. The address a relative mode parameter refers to is itself plus the current relative base. Okay, so that means if you're talking about a certain parameter, like let's say this one, and it says 5, and this one is actually in relative mode, so I'll highlight that with yellow, and then 5 means actually this position plus 5, and then you end up here. Yeah, okay, I think that is pretty clear. And anything else? Hey Willem, I see you joined the leaderboard, cool. I'm going to make sure that your name shows up right. Give me just a second for that. All I need to do is add you to my configuration file, and that will not take a long time. And your Twitch name is Sir Chowtik. So there we go, that one was added, and then I'll just make sure you get the nice green color that other people have. And now, in a few moments, you should be able to see that. Alright, I think we're almost ready to start programming. We have some examples, there's some more information here. Some examples. You will also need to add a few other capabilities. The computer's available memory should be much larger than the initial program. Memory beyond the initial program starts with the value 0 and can be read or written like any other memory. It is invalid to try to access memory at negative addresses though. So what that means is that, let's say our program actually ends here. So this is the end, in the sense that that's the last input of the computer. Then we're going to have some extra memory behind, and you can read and write from it. And I suppose all of it starts with 0. Now let's see. It should be much larger. Memory beyond the initial program starts with the value 0 and can be read or written like any other memory. Okay, so we have 0, 0, 0 here. Now I have one question, and it is, do we need to pre-allocate a bunch of memory, or will we just basically increase the size of the program on the fly? I think the second option makes a little bit more sense, because probably we're not sure how much memory we're going to need in advance. So that's what I think I'll do. I'll just expand this one flexibly. You were quite scared when you saw IntCode, but this seems doable, right? I think the previous IntCode puzzles we had so far, 3, were quite tough. This one might be alright. And now we have another requirement as well. The computer should have support for large numbers. Some instructions near the beginning of the boost program will verify this capability. Oh no, I hope it's not going to be numbers that are larger than what Python can handle as a standard integer. That means if it doesn't, we have to switch our library. And actually that's not too much work, because all we're doing so far is adding and multiplying basically, that's it. So we can probably easily find a library that does this. So I'm actually not worried about that. So we have 3 requirements. I'm going to write it down. Requirement 1 is having the adjustment of relative base. Requirement 2 is having the memory, and requirement 3 is having super large integers, and they should be 16-bit. So those are the things we're going to do. I'm going to start, and that means that also I'm going to have the same problems as I had a few days ago, where my module imports don't work very well. How I solve that is to, so the problem is I need to import modules from other days, and I maybe shouldn't have put my IntCode computer in other days, but that's what I'm doing now anyway. So I need to run all my code from the parent directory instead of the day directory, and that has some unhappy side effects. So we're going to start with writing tests, of course. So the last IntCode day was day 7, where we had the amplifiers, and I did change some code here I extended the IntCode computer from day 5 into day 7, and I added linked output and load from file. I think we're probably not going to use that one again, but just to make sure I'm on the latest branch, so to say, I'm going to make another IntCode computer from day 9. IntCode computer day 9. That one extends the IntCode computer from another day. Day 7. Let's keep the naming consistent, and we can import that and pass. And then we're going to have some tests. And my tests look like this. I have examples. Those are literal examples from the puzzle, and also I add my own ones. And then I have tests where I actually run the program on the input, so to get the final answer. Sir Chowtek, you're saying you're actually not sure how to account for large numbers, but you'll take my word for it. Well, don't take my word for it. It's my best guess at the moment. And of course, we're gonna see if it works out as intended or not. So I'm copying my final solution test class and removing what I don't need. I have a test for part 1 and a test for part 2. And I need to import my unit tests. And I will duplicate this for the examples. Thank you very much. You're very agreeable today, Willem. Well, as always, actually, you're such an agreeable person. But let's see. Open mind, curious how it will go. So we are starting now with the relative base. We need to make sure that when we have a value, actually what I notice right now is that I don't have a cursor, and I might be able to show you where my cursor is like this. No, it doesn't really work. Yeah, so something I'm missing in my current streaming setup is being able to point out where I'm looking at on the whiteboard. So far I've been using my pencil for that. So if we have a value with a relative base, we need to look up where the active relative base is and then jump that amount to the right or left depending on positive or negative relative values. So a test for this. That means we're going to have a computer. Like this, and we're going to have to write a program, and there are some examples already, so maybe we can just use that one. Here are some example programs that use these features, so they use all of those features. I think I'm not going to start with a test that does everything. Relative base is 0 in the beginning, and that means that if we are going to run a program that let's say outputs relative address 2 or 3 and then halt, then let's see, relative base is 0. I'm just thinking what kind of program we're going to make. I want to make something like change relative base. No, we keep relative base. So relative base is 0, that's just the starting state. Then our first instruction is to output position 5, I think, and then halt. So we start with an output, opcode. We need to import that, opcodes, put out. Output. Hey, why does that not work? Oh, those are only the opcodes. I need instruction set. Yes. So I have opcodes for just the base opcode, but for the instructions that also have the parameter modes, we need to have the actual functions. So we're going to output in relative mode, modes REL, and that's something we don't have right now. So I'm going to have to add that right away. And the relative mode, I guess, is 2. I'm not sure I saw that actually. Yeah, parameters in mode 2 are relative, okay. And output takes only one extra argument, and that will be, let's say that we output position 5, and then we're going to, let's see, and then we're going to halt. That's all we need to do. I don't have an opcode for halt actually, an instruction for halt, because basically it's the same as an opcode, but just to make it a little bit more readable, I'm going to add that one. And also, since we're building on top and on top of this IntCode computer, it does make sense to actually clean it up every now and then. But this just returns the halt opcode, and that's it. And that means that our location where we're printing, what we're printing, is this one, and that's at position 0, 1, 2, 3. So I'm going to use relative mode 3, and then we're going to run it. Run program. No, wait, this was actually the running instruction. We don't need input. And we're going to assert that our output is going to be 3. We have only one output, so a list of 1, value 3. Computer.output. Now normally you would run it like this, of course. In my case I cannot do that because of this relative, because of my working directory that's one level up. So I'm going to run it like this. Maybe after the puzzle we can try to solve this issue if I have enough time. So 42 is the output and the test passes. That's the basic case, and I'm going to make another case for where the relative output base, relative base is shifted. So we have a relative base of 0, then we're going to shift the relative base first, adjust relative base, and adjust relative base takes one parameter. And now the question is, of course, does it also support parameter modes? I suppose it would. The only parameters that do not support relative modes are supposed to be the output parameters. So let's say we shift it by 2. And we're going to go to, let's say, no, the argument actually should follow it. So we are shifting it by 1. And that means that if we are going to, that's my interpretation too. So all parameter modes included as usual. Yeah, that's what I would guess as well. By the way, Willem, Sir Chautik, are you working on the problem as well? If so, I'm sorry if my babbling is distracting to you. Feel free to mute me if you need. Adjust relative base by 1. So that means that if we are going to read from position 0, 1, 2, 3, 4, 5. So normally we do 5, but we shifted the base by 1. So now we can read from 4 and still get 42 as an output. By the way, I realized that what I was doing here is an incorrect test. You're doing industrial espionage. Very cool. Well, I don't mind that. There's a lot of puzzles also. I can imagine also doing all of them is quite tricky. And feel free to watch and learn. Or watch and help if I need help. Actually, in this case, we need to output 42 and not 3, because we're actually getting the value and not the position. So we need to dereference it, and we don't just print 3. So that means this test is going to fail, which is correct, since we have no implementation yet. And now we're running both tests, and tests part 2 are going to be failing after I change it into 42. Okay? So I see that already Zarankiewicz has finished part 1 and part 2. Stavoy also has so. Hi Zarankiewicz, welcome back on the stream. Amazing, so fast in less than 20 minutes. Little addition, you can see the leaderboard now also shows which of our members are on the stream and which, like how much time has passed since the start of the board. And also I noticed that Willem, I'm sorry, your name is not showing correctly on the stream. Looks like that, at least on where I'm looking. Oh no, it's actually working. I have my own preview of the leaderboard and there it's not up to date yet. I think it's a Safari issue, caching or something. Okay, so this was quite fun, you say. What made it so fun? I'm also enjoying it. What are your reasons? So instruction set has no attribute relative base, of course, because I haven't made that one yet. And relative base also takes modes. Yeah, I do have some wizards on this leaderboard. Some of these good guys and girls finish the puzzle really before I even start on it. And I start on it as soon as it is released. And I've read the instructions. So we have modes REL. Or no, oh hold on. So for adjust relative base, I guess we need... Well, I'm actually not sure if we need a mode for a relative base, because it is always going to shift it relatively by the value of its only parameter. I think I'm actually not going to add modes to this operation, because what would it mean if there's a position mode? It would mean you go to the position. Let's see, just like this IntCode stuff. Okay, that's cool. I also like it actually. So a relative mode for a relative base adjustment would look like this. So you're reading position 9, and if it is an immediate value, it means you're shifting by 9. Well, 9 was actually the opcode for a relative base, but let's assume for now that this is also the value to it. So then if it's an immediate value, you're going to shift 9. If it's so that's immediate. If it's a position value, you're going to look at index 9 here, see what's in there, and then like let's say 7, and then shifting 7. And then we have also relative base mode. Oh my god, that's going to be crazy. Relative base mode would be that you look at the relative base and read what's in there and then shift by that amount. So let's say it's 8, then you're going to shift by 8 relative base, and this one was position mode. So there's actually a lot of ways you can jump, and I think, considering the power of what you can do with that, probably it is going to be part of our implementation. I think it's never mentioned explicitly, so I'm going to assume that it should work. There might have been an example, but I don't see it. Okay, let's just assume that we need to have these modes, and that for this case it is going to be the immediate mode, because we're adjusting by literally 1 and not anything else. Okay, we can run the code, and now we should have... We still don't have adjust relative base, so I'll add this method. And we need Do we need 2 parameters? I haven't added 2 parameters, so that's really quite weird that it's suggesting us to have 2 inputs here. So we have first mode, and we're going to return the opcodes. And this is going to be adjust relative base. Adjust relative base plus 100 times the first mode. You can see I'm just repeating all of these things. It's not super clean, but it's short and it's all on one page, so no harm done, I think. And ARB is going to be opcode 9. And then we can run our code. I wonder why this is purple and not... Oh, it's changing it into class method instead of static method. I see. I have to learn one day what those mean, because right now I'm not sure. And now we can run it and we get some output. So it looks like our program is empty actually. Or what's happening? Key error 9. Okay. So output mode relative 3 should output this position. And I'm actually curious why it doesn't work. If we use positional mode and we would just run, it would definitely work, I would say. And I have to run again my file and not the individual test case. Hey Crespol, good morning. Welcome back on the stream. How's it going? You already solved it, I see. Good job. And I'm still working on part 1. I've just read the instructions, made a little overview of what we're going to do. All the big boxes in red are what we're going to add today. Right now I'm still working on relative base, taking it a little bit more slow today. Just in Ruby so far, and no Crystal. You need to sort out your switch to int64 for Crystal. Oh wow, so apparently that's a little bit more complicated than just than what you would do in Ruby. How come actually? Does Crystal use a yeah, I guess it uses a certain compiler that Ruby doesn't use. Okay, so where are we? We are running and we get key error 9 and we have our output description here and it's not showing any output and I'm not sure why that is. We have mode count and we want to count the mode for opcode 9 and that doesn't work. Okay, then no problem. That means that we have to go to day 5 where it's mentioned and add also the parameter count for op adjust relative base. Adjust relative base, I don't have it here. I'm going to import it from opcodes. You see I haven't refactored everything yet to be defined only once, which is alright. Ruby will automatically promote int types as necessary. I need to be a little bit more careful with Crystal static type model. I see. Yeah, that makes sense. So I guess you're going to refactor that right now, or maybe at some later point in time. So let's run again our code. Key error 9. This is a way of writing code that I like sometimes. Just write a test and run it and see where it crashes. You'll figure out soon enough where you need to make adjustments. Another problem with opcode labels. We haven't defined that one yet. We're going to print it as adjust base. Shorthand so that when we debug we can see it clearly. So now we can actually see our program and how it's running. So we have an adjust relative base instruction for part 1. That's not right. This happens all the time. Relative base of 0 and then here we're going to do adjust relative base by 1. So in Python, if you have 2 methods with the same name, it will just run it without complaint and it's not going to be clear which method will be run. It looks like it's the last one. So our base case is this one, and we have an output of 42, and that one passed. And the one that didn't pass is the one where we moved the base by 1. So to improve our computer, we are going to have a initializer that will set the relative base to 0. Relative base is 0. And yeah, you know, I'm extending from my computer, but actually it doesn't seem like I'm actually able to put all those things in different places. So I need to handle the relative base adjustment instruction, but I'm not able to go to do it here because all my input handling is done here in the execution loop, and that one looks like this. So probably it would be better if I would just like add lambdas to each opcode, or I would like register opcodes in some way. That would not work very easily. For example, when I have a return or when I have to do break when I finish the program. So that's going to be a big refactor, and I don't want to do it today. So let's actually add it here and make a big to-do. Move opcode logic to separate functions, methods that is. And so in case that the opcode that we're dealing with is the opcode for adjust relative base, and that one is not recognized right now, but we have it in opcodes. Maybe we don't. Oh yeah, we do. Okay. And for halt we're going to break, right? Did I just remove the break statement? It looks like halt. Wait. Yeah, this is what we had before. Okay. So if we have a relative base adjustment, for now we're just going to pass, and we see that we can run the rest, and we are going to parse the parameters. So that's going to be one parameter, and the parameter modes are the modes, let's see, that are passed into the instruction. And we are going to look up the output instructions for this particular opcode so that we are not going to dereference that one. And output positions for op relative base, adjust relative base, is actually empty. We don't have an output position for this one. Right? Yeah, my PyCharm is really quite slow. I think it's because I'm streaming and I have a bunch of widgets also. It just makes it a little bit more slow. Hi, welcome to today's program. It's day 9. I see you've probably solved the puzzle and decided to come in. Welcome again. I'm still working on part 1, and I'm working on implementing relative base to our code. I'm not as fast as usual. I'm explaining a little bit more so that everyone can also see what we're doing. List index out of range. At which point do we get this? We have adjust relative base by 1, and then we get list index out of range. And we get it in the get parameters function. So probably we're reading from output parameters or something. No? Let's see. We do a double dereference. That means our program is going to think that this is a positional argument, but actually it is an immediate mode, and we're still dealing with the adjust relative base function here. Okay, we are going to have to debug this. No problem. List index out of range. What does it mean? We have parameters here, and are we actually passing along the parameters in the instruction loop? So the parent function is this one. We are getting, let's see, The number of parameters we need is from here, and parameter modes are parsed by the parse instruction, and that uses the up parameter counts. And I said that we have 9 parameter counts, and that's just a typo. That should have been 1. Okay, now we can see that we actually are able to finish the program, but it doesn't work correctly because we haven't shifted the relative base yet. So to make our program a little bit more easy to understand, our computer rather, I'm going to also print the relative base, and that means that again my object-oriented structure with a class hierarchy is not helping me a lot here. I'm going to need to move the relative base to the parent class so that I can actually add it to our debug statement. It's very silly, I would say, but we have no other way other than refactoring, and I think that's going to slow us down too much. So when we reset our program, we want the relative base to be 0 also. And what else? When we do the debug statement, that's around here after every loop, before every instruction, we are printing here the slashes, as you can see, like this, and the relative base is going to be there as well. Relative base like that, maybe like this, relative base, and now you will see it that it didn't change. And now we're going to handle this operation. That's the halt, and here we get some output, value A. We need to unpack it because we do get tuples like always, and to unpack a single tuple it looks like this. And then we're going to shift the relative base by the value. That's it. No, that's not it. We still need to implement the reading from the relative base. So that's something I can actually test explicitly with an instruction or with a computer where I override the relative base. So yeah, in Python everything is public, so I can actually change that internal position. Maybe it's not the most nice thing to do, so what I can do, I can just make a function for that. Or you know, whatever, I'm just going to change it to, let's say, 1. So we don't need to adjust the relative base, and we're just going to run. And now the thing is, I need to load the program and then run it with the relative base intact. So I'm going to do it like this: load program, then set the relative base and then run it. And then we should get 42, although 0, 1, 2, 3, this position is 3 with a relative base of 1 that would be read with relative mode 2. And let's run it. And we see that we actually... Ah yeah, I'm overwriting the method name again. So relative base read. This is adjust relative base. And this is base case of 0. Good morning, Fuzzy McFuzz. Welcome on the stream again. You've also finished. Good job. How was it for you today? Was it tricky, or was this one of the most easy ones? We're already 40 minutes into the stream almost, and I'm still working on part 1. I'm taking it a bit slow today, just to see how it feels to do it a little bit more calmly than being all stressed out and stuff. Stressed out in a good way, of course. So yeah, here we can see that our relative base read is not working. Simple enough. I wish there was more to do for part 2. Okay, that relieves me a little bit. That means probably I am able to finish it on time before I go to work today. I do have to go to work, and I'm working in Brussels, which is not where I live. So I need to take a train and leave on time. Right, so now we need to make sure that our relative mode works, and that is actually handled in get parameters. So get parameters takes the modes and decides how to read the values. So else if the mode is mode, what we call it again, relative, it's in modes, then we're going to do something else, and it's not recognized. Oh yeah, because I just need to write it like this. I still have a bunch of cases where I didn't refactor the kind of global constants out yet. I'm going to do that right now. Maybe except for those two. Modes dot. That should solve it once and for all. And we're working on parse get parameters. And here the parameter is going to be from the positions array. Well, yeah. And we're going to read from the relative base. That's it, right? Hold on. We're parsing a parameter. Let's look at the code again. Becoming a little bit messy. So let's say we're looking at this one here, the 5, and it's, let's say there was an instruction here, like I, and it has 5 in relative mode. That means that we're going to look up the relative base and then add 5 to it, right? So it's basically the relative base plus the value. And here I'm getting the relative base. I'm confusing myself again. So again, to the drawing board, we are reading instruction I, and we need to take, we need to give it value 5. That means we need to go to the relative base, but not the relative base's position. We need to read from memory still. We need to read from memory, and the location we're going to read from is determined by the active relative base. So I'm going to say memory location is this one plus the value. Do we have the value? We have the position at the instruction pointer. So the value is going to be the value at the instruction pointer. No, going to be the value at the instruction point plus index plus position index plus 1. That's the value. And so that means at this point we have 5, so to say. Let's go to the drawing board. So now we've extracted the 5 itself, and now we're going to have to add that to the active relative base. So we have active relative base plus value, and we're going to dereference it from the location that that is pointing to. So this is actually the parameter's value. So the location is here. No, relative value. Like this, kind of the same as here. Basically, we're doing the same as immediate mode, and then we're going to use this to determine the parameter. That's it. Okay. It's very confusing with a lot of jumps and stuff. Okay, so actually we did pass all of the tests. So the relative base adjustment is working. So I'm going to highlight that here. So we have a bunch of nodes that we don't need anymore. So I'll give a big check mark to the relative base. Now we're going to go on to the parts about the memory. So memory works such that if we are writing or reading from a position that was not kind of reached yet or was not defined, then we're just going to return 0. That means also that our program is going to grow kind of automatically. So for this I want to make a test case. And the test case, I have to give it a name this time. I will do that. Let's say read from memory. Read from unallocated memory. And we need a computer. And we can run the program right away. And we're going to pass it. Let's say we're going to output the value at a certain address, like the literal value, so that it means mode immediate. And then we're going to halt, and we're going to read from position 500, let's say. And then we want the output to be 0. Computer.output, like that. Let's run it. And we are going to get an exception, most likely. Lists differ. We actually only get a failure exception. We don't have a crash. That's a bit strange. I was expecting to get a crash. Why don't we get a crash? Output 500, and then we're halting. Okay, I'm going to use debug mode and figure this out. So we're here, we're going into our program, skipping over the parameters. I already missed it. I'm going to put a breakpoint right here, inside the execution loop. We run it again. And let's see. Our first instruction is going to be the output instruction. So that means that we're going to end up here, most likely. Oh, did we just go here? That means that we're already at opcode 9. I think I'm running a different test than what I'm thinking I'm running. And that's because I am no longer able to run tests individually. Very annoying and a bit difficult to get used to. So I need to run again like this. And we are going to run again until we get out. And it says we need to output the value here, which is 500. Okay, but that looks like an immediate value instead of a position. So that means the test was not correct. We don't want to output just the number 500, we want to look it up from the memory. So let's go and fix that. Now we should get an exception, list index out of range. That's really what I wanted to know. And to make that a little bit more, I wanted to say I'm gonna make that explicit and actually throw an exception. Oh, by the way, I forgot to turn on my light here. That should help a little bit. So I'm not going to throw an exception because right now I'm actually at the point where we're going to always have memory available. Oh yeah, it's difficult to it's tricky to remove this line because actually there's something there. This would make it a little bit more clear. Okay, so why is this still being highlighted? It's just a bit out of sync. Okay. Wow, Zirankiewicz, you're so much on the top, actually finishing everything so soon. You were not the first one today, but you're still leading the board. Crazy, hard to catch up with that. I'm 87. 87 points. So where we are looking at the part where we're reading code, where we are reading, and value is going to not be filled in because get parameters actually cannot read. So I'm going to add a function for reading, read position with a certain position, like let's say, we'll just call it position. So sometimes a bit hard to talk and write at the same time, so that's why you might sometimes see me write completely irrelevant words, or maybe relevant but not actually what I should write. I'll just write what I say. We're going to read from the positions, and if it doesn't exist, we're going to return 0, but also we need to extend our memory. At least that's what I think we should do. Although for reading it might not be necessary. So if our position is bigger than the length of our positions, like that, then we're going to return 0. Actually, that's still fine for now. So if we have an empty list and position is 0, that means that it's already out of bounds, so we need to check it like this. You had a silly bug today that you couldn't trace. Aye. Yeah. Can be frustrating if you have all your code done, but it's not working. Yeah. Okay, maybe you can show us if I am able to finish this on time. Read. So every place where we're reading, we should now use the read function. The parameter is self.read at instruction pointer blah 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 plus 1. And here also, I should have basically just extracted this, but oh well. Not sure if that actually would be possible or easy even. And here also, self.read. Reading a lot in this little application. Okay, now let's see if we're, oh yeah, we also have to have an else case, of course. Self.positions position. I'm going to do a little search to see if I'm reading anywhere else. Yeah, I do it at the point where I'm taking my instruction pointer. I'm not sure if I want to implement it there also. That means that if you don't have a halt, that you would continue forever doing 0 instructions, and 0 is actually not an instruction, so it would crash. It would still crash, which may be fine. So I'm not going to actually expand memory forever here. Okay, we're reading from unallocated memory and that works. Now we're going to write to unallocated memory. And that's going to be in day 9. Another test. Oh, by the way, my other tests should of course still work. So I'm going to run it like this. All tests pass. And let's see if I can actually extend from examples in day 7. Import this name. No, and then we get no tests were found. So I really don't know. Oh, maybe I do know how it works. We might need to generate. I was thinking we need to call the parent class. Does anyone know if in Python you need to always call the parent constructor if you're extending, or if it's not necessary? It's just some Python thing that I don't know. I would think you don't need to. I mean, Python is made for usability, and that seems something a bit of a mental overhead to do. Only if you have your own init. Okay, so if I override the init, then you need to call the parent, otherwise you don't. Thanks for that, Fuzzy. That means that I'm going to have to run the test for day 5 manually. So they all pass, and day 7. How about day 7? By the way, extending from another day's test classes worked before. It worked until I was running my tests from the parent directory rather than the local directory. So unfortunately, we have to do a lot of manual stuff. So we have reading, now I want to do writing. The test is probably going to look a bit similar. That's actually relative base read. I'm going to call it... I copied the wrong test case. This is the test case I'm going to copy. Write to unallocated memory. And then, of course, we also want to read from it. Write and read unallocated memory. So we are going to first write. That means we're going to do output. No. Writing is... How do we write to memory again? Output just shows it. And what other opcodes do we have? We have add, we have EQ, we have out. Out just doesn't write anything to memory. I think we need to do something like add. That's the only one we actually can do to set a value. We don't have a setter. Unless I'm missing something. We don't have a setter. Interesting. Okay, so let's do an addition then. Int should set something, that's the input. Right, yeah, of course we can use input. Thanks. So let's say we're inputting the value 42. That's the inputs array of input. And that takes no mode. And then that's it. Oh yeah, and then the position where we're going to write to. And let's say that's position 500. And that will always be immediate. Well, it will always be position mode rather. And then we're going to output what is there and see if it works. And I'm having a syntax error here because my inputs is an array. And let's see that we actually get 42 as the output. I don't want to run day 5, I want to run day 9. Shout out for any fans of day 9, by the way. If you've ever watched StarCraft streams a few years ago. So we get a broken test. That's what we expect, of course. List index out of range. And that happens in the place where we're actually handling input. That makes sense. So let's say we write in position here and then an input. Day 9 streams got me into Dota 2. Great guy. Yes, he is a great guy. I heard that he doesn't stream anymore. I haven't watched a lot of his videos, but I was introduced to online streaming from through day 9 basically. Well, from a friend who told me about day 9. Pretty cool. So we don't need this one anymore. And do remind me to check if I'm reading or writing from the positions array directly anywhere else. Write itself. Oops. Thank you for auto-completion. And we need some value. Day 9, last time I checked, it was chiefly Hearthstone. Not sure what he's up to right now. Oh yeah. So he's actually, he went on to do other games. So writing like this is not possible if we don't have enough space. So let's check if our positions array is long enough. So the length of our positions array is, if it's less than position. So let's say position is 1 and our array is 0. That means that we're going to have to expand. And in this case, that's the edge case and it would trigger and it would work correctly. So we're going to have to replace our positions. We can actually append to it, right? We can append to it the number of items that we need. We can do repeat. I think repeat is what I need. Sorry for the rhyme there. 0. Hold on, how does that work? My Python console is broken also, so I'm going to use interactive console. Doesn't it work like this? Yeah. So just a multiplication. We do 0 times the number of extra memory that we need. And the extra memory we need basically is our position minus the length of the positions that we have. I'm writing like a noob a bit. Hey, come on. Okay. So if extra memory is less than, let's say bigger than 0, then we're going to flip these. But we cannot flip it because it would change the semantics. Right. So we have more positions than the position we're writing to. So this should always be positive in general. Unless we have too little, then it would be negative. Okay. So we actually do need to do it the other way around. So if we have more than 0, right? If we have more than 0, then we need to append. Okay. And is it actually in PyCharm that's checking for negative multiplication? No. Okay. So that was it, and then we can just add. Okay, let's try that. He doesn't really do StarCraft anymore, but definitely still streaming. Okay, cool. I should check him out. These days, Magic the Gathering, Dota 2 with Purge, and various adventure games on Thursday. I'm going to actually cover up my own face because I tend to keep looking at my own face. It's handy to know if what I'm like, if it looks alright, but it makes my eyes look closed. So I covered my own stream preview right now. Very good idea. List index out of range, so that means it's still not working correctly. Oh, look at that. I already had a write function. Really? Oh, now I have another one. See, I have this all the time. Like having 2 functions with the same name. I really should get rid of that habit. Let's see. And now we get list assignment out of range. Even though we did try to add extra memory. And I'm going to disable all the other tests and then run only this one in debug mode. And let's see, here we are jumping. We need to go to the write function and then wait here. We continue. And we're trying to write to position 500. And the extra memory that we need is 5, and that's because our positions right now have 0, 1, 2, 3, 4, so that means 5 elements. And yeah, I think we need to add one more, because if we're reading to position 500, it doesn't mean we need to have 500 positions. It means we need 501 positions. Right? List index assignment out of range again. Let's just debug and see. So the extra memory we need is 496, and if that's more than 0, which it is of course, then we're going to append, and our position list looks now like this. Okay, maybe we can check the length. It's still 6. Huh? How is it still 6? Oh, I just added an element with 496 elements of 0. So we need to extend and not append. And probably you can do plus. Or maybe not. Otherwise, why would they have extend? In Python, the idea is that you don't have like 10 different ways to do the same thing. Or maybe, is it? I feel like Python has quite a lot of standard ways of doing things. Oh yeah, of course I can use the plus operator, but it wouldn't change self.positions. So I have to use extend, otherwise I have to override it. And I'm not sure if I'm using references to positions. And if I would override it, those references would be broken. So for now, I'm just gonna do it like this. And we are okay, cool. It's about an hour since we started on part 1. We've implemented already the relative base, and now we're implementing the extendable memory. Extendable memory, nice name. I think that is a name known in computer science. Not exactly sure, but it sounds like that means something. So I say that we are done with that test. Did I disable all of my tests? And do I need to rerun them? Yeah, I did. But they're all passing, so that's fine. So we're reading and writing. Cool. And yes, reminder to myself was, am I reading or writing to the positions still? Not in this class anyway, but here maybe. So we have it here for dereferencing the instruction. We have it here for doing an add operation. So that means I didn't actually implement that part yet. For that I'm going to make one extra test, and then I'm really going to continue with the last part. But just to punish myself for not implementing it fully, add to unallocated memory. So we're going to do an add operation like this, and the first mode is going to be let's say immediate. So we're going to add 42, and the second one is going to be a positional mode, which is 500, and I want to add those two together and then output it and then halt it. So the answer should then be 42 also. And that doesn't work, as I said, because here we're not actually using the write function. But we do get a key error though. That's something different. That's a different error than what I was expecting. So we add, oh right, we need another value for where we are going to store. So we're going to store in position 501, and that means that our output, let's say, okay, so we're going to output position 501 as well. And let's see if that works. Yeah, now we get actually an exception in the position that I was expecting. So here we need to do self.write, output position. Autocomplete is not working right now. LC, there we go. It's still being highlighted. Okay. And anywhere else, the multiplication also, it uses the same name, so that's easy. Searching more. Here we have an equality check. That is also an assignment. So we're writing value 1, and otherwise we're writing value 0. And I guess that the examples that are provided by Eric on Advent of Code are also going to help us check if it works completely well. And as it was written in the puzzle for today, the boost program will actually verify all of this. So basically we can sleep well, because we know that if the test passes, it really works. Here we're also doing a less than operation and writing somewhere if the case is true. So that's this one. And anything else? We're returning a result. Yeah, I'm not sure if I'm even using this function anywhere. I don't know. I don't think I am. Just to be sure, I'm gonna check the tests for day 5. Let's run them again. Yeah, they still pass. Okay. And then searching. So now I'm pretty sure I'm not reading. Oh, wait, here I'm still reading. Right, okay. So I'm reading here in the input operator code. So instead I'll do self.read, and that's it. And now I guess we're really done. Yeah, 3 positions only. Good. And then we're running day 9. Run. And I'm going to input now the examples that are provided by Eric. And we'll just copy this one. And then this one. By the way, what do you think of the music? Random question, so I can learn a little bit about what I can change in this channel. Add to unallocated memory. No, this is just example 1. I'll just call it examples. Nice and relaxing. Cool. I guess if you really didn't like the music, you would have already left. But sure. Cool. Yeah, seasonal. That's indeed seasonal, yes. Alright, cool. Yeah. I actually am not such a Christmas person, but because of Advent of Code, I just like to do it all in theme, and now I start to enjoy it like much more than before. And wearing a hat every day also helps to add to that. So this is our input program, and do we take... It takes no input and produces a copy of itself, so we have no input. So because it outputs a copy of itself, I'm going to call it program1 and just check that the output is the same. Program1 computer.output. Everything passes. That is very nice. Now for the digits. So we have a 16-digit number that needs to work. I'm not sure if it's going to work actually. Maybe Python can already handle this. Like this. It should output the large number in the middle. Hold on. This one just says it should output a 16-digit number. 16-digit, not 16 bits. I think I wrote 16 bits before. Oh. Large numbers. But they don't say how kind of large they should be. Okay, so they don't have to be 16 bits or whatever. Actually, integers are 32 bits. What am I talking about even? Although they are signed, so you only have 16 bits for the positive and negative range. I do feel the need to complement the hat. Not sure why I haven't yet. Yeah, why not? Why not? Well, thanks. If you meant to say that you want to compliment me about the hat, or do you mean that you need to compliment yourself with a hat? So let's run the test, and we do get okay. The first, no, we now actually get a problem. So let's make it into a separate test. Yeah. Large int. So probably the large int doesn't work. Actually, I have a test here that doesn't make sense. I'm not sure how we can test that this works. We can of course run the program and see what it's supposed to do. Probably it's going to multiply those numbers. So the large number is doing a multiplication, and I think my debug mode is not capable of outputting the values correctly on the screen. But that's okay. We can see right here that it's going to multiply those two, most likely. And that multiplied by each other is... Oh my god, that is a large number. That is a very large number. That's not 16 digits. Oh, it is 16 digits. Okay, let's see if we can actually copy that. So So I copied it from my calculator, and the output should be like this. And actually we get okay, so I think we're fine. So we did all 3 parts, and now we get our puzzle input and save it. And we can solve this thing. So for the input, I'm going to read the file, which is done with file day9 input.txt as file handler, and then turning off the big light here. Wait, isn't it file? It's open. Every time, like every single day, I mess this up. We're going to parse it, file handle read lines. Although I do have an actual way to do this more simply. We can just do like computer.load from file, and then do day9 input.txt. And then what do we need to do? What do we need to do? The boost program will ask for a single input. Run it in test mode by providing it the value 1. Okay, so computer.input 1, and then computer.run program. And then if it's functional, it should report no malfunctioning opcodes when run in test mode. It should only output a single value, the boost key code. What key code does it produce? So let's print it and run it. None. Oh, I'm printing the output of run program, but I should actually print the outputs. Like this. And day 9 solutions, part 1 is here. And it says 203, but I get 2 codes. It should report no malfunctioning opcodes when run in test mode. It will perform a series of checks on each opcode, output any opcodes that seem to be functioning incorrectly, and finally output a boost key code. I'm going to add write 203 here. I think it's probably wrong. Yeah, it is wrong. Okay, but it's not really outputting a malfunctioning opcode because 203 seems to be. 203 means get with relative mode. Okay, let's look at the opcodes. So we have opcode 2, which means multiplication, and then relative. Yeah, it's very cool that it tells you what mistake you made. 203 is certainly an opcode. That means it's number 3, input, right? And then it means, but input takes only 1 argument. And wait, let me show you what I mean. So I'm going to have a little bit of help today. That's fine. So 203, that means that this one is opcode 3, which is in, am I right? And then this part should be the parameter modes. That doesn't make a lot of sense to me. So it means it's an operation. Oh, the right 2 digits are the opcode. Right, thanks. Yeah, that's a mistake. Yeah, right. Okay, so 2 is actually a relative mode. Okay, so our input with relative modes doesn't work right now. That can be the case. So let's look at our execution loop and see where we do in. And we do in right here. And we're writing it. And where are we writing it? We're writing here. We do self.read instruction pointer and then writing it. Oh, we're actually not parsing the parameters for up-in. But isn't the parameter to input Isn't it an output position that should always be in positional mode? Yeah, indeed. I also thought so. No, always in positional mode, although you do have to kind of treat it as if it's immediate, but the values there always indicate a position in the list. So right, you just disallow immediate mode for input. Yeah, okay. So that means that I actually do have to do get parameters here on input and specify how that works. Well, that's not too bad. And yeah, the self-test really actually shows you where it's wrong, so that's cool. Well, I know that this entire puzzle was made in good intent, of course. Yeah, okay. So we have our instruction pointer and parameter modes and output positions. I noticed now, by the way, that I'm calling this function in exactly the same way in every let's say operation code handler, but the number of outputs is just different for each of them. That's the only difference. So it should be like this. And then let's look at the number of positions for oh, but I'm afraid now that I actually can't handle it. We know that if it's an output position that we're always going to do it in this way. And but we do pass modes though. So I guess only if the mode is immediate, then we're going to do this check. So if the mode is immediate and we have this guy over here, then we're going to handle it like this. I think maybe and not. Let's say and not. We're not. Oh, I guess I want to make a separate case for the case where we're dealing with an output. So let's say that the position index is in output parameters. Then we're doing something else than if we're dealing with normal inputs. And for immediate mode we handle it like this. And here we can also check if the modes are relative. Okay, then we need to do this relative stuff. I don't like it very much. No, I want to reuse that code. Definitely want to reuse it. I think the way AOC thinks about this is as follows. For x, an integer, positional data x, okay, relative is data x plus base, and immediate is just x. Yeah, it makes sense. You mean for input? Like taking the number 1 as input, that doesn't make a lot of sense. If you wanted the number 1 as input, you could just store it in that position. But of course, basically input could be used as a simple write function that way. No, but the argument is where you're going to store it. You cannot store it immediately in the number 3 or whatever. Yeah, right. Yeah, you can't write to a literal, right? So if we're in immediate mode and we are not dealing with an output position, so we have a position index that is not in output parameters, and we can do it this way. And if we have a mode, if we are dealing with a case where the position is in fact an output parameter, then we have two cases, but maybe those cases are handled here already. So this is positional mode. I'm just going to make it explicit. No, I don't have to make it explicit because it's sometimes well, I'll make it explicit. So either we have a position mode or we're doing immediate mode, so to say, and our position index is in the output parameters. So now we have all the cases explicitly, right? We have immediate mode for non-output. So I'm going to extract that like this. You know what? I'm actually going to run the code and see if we get a pass. No, we don't get a pass. I broke a whole lot of things. What did I break? I think we have some ors and ends, and I might need to put some brackets around it. And here we have problems. Yeah. Do we need another case? What did I just break? This is mostly from day 9 that broke. But how about day 5? Completely broken. Okay, so that was not a good refactor. I'm going to actually revert that. So we have relative mode here. I'm going to revert it, but we do need to do that read stuff that I made before. So I'm just going to do Command Z. Right? Like this. So day 5 works and day 9 doesn't work yet completely. Or does it? Yeah, it does. It does run, but it doesn't give the right output. Let me actually commit this because I'm afraid to mess up some things. Day 8, that's not so important. Instruction set was changed and some constants. Okay. So day 9, part 1, work in progress. We're almost there, aren't we? Let's see where we need to go, what we need to do. I'm a bit surprised that this input has also a relative mode. By the way, input, how did I define it? Does it have parameters? I said it has 1, and we have the output positions for each of them. And I said that the first argument is an output position, in fact. I'm going to write down all the cases. It's a habit I'm trying to build, that in case I am stuck, that I will just go to the whiteboard and write it all out. Let it all out on paper. Or a screen, whichever you're using. So we have a few cases. We have an output parameter and we have an input. Input has immediate, it has positional, and it has relative, and output has positional and relative. But basically, if you're doing immediate, it just means that you need to use the positional argument, positional mode. So what we can also do is just have the same code as before, but just like override the mode. And what I'm using for this whiteboarding is an iPad Pro with an Apple Pencil. And I've hooked it up to a tool that allows you to cast it to your laptop. And I'm capturing that one with OBS, Open Broadcasting Software. And I'm overlaying my iPad screen on top of the rest of the screen. And I must say, after I'm really plugging here for Apple right now. I'm not an Apple fanboy, but I really am using this stuff a lot, writing down everything. It's so handy. And for streaming, it also works quite well. You can use it in presentations when you are presenting for your company and you need to draw some diagrams on a big screen or on Skype. I find it super handy, and it's intuitive as well because you just write on the screen itself. So yeah, what I was gonna do, I was doing get parameters, and I'm just going to check if we're in output mode, like this. Is output, and then if we're doing output, and the mode is modes.immediate, then our mode is going to be modes.pos. That's all. And the rest will be the same. Right. Okay, we are getting underlines because PyCharm is slow again. And now everything breaks. Everything breaks. So let's go to the test where we do inputs. We do have tests for that, of course. And look here, what is going wrong. So we have a test program where we start by reading an input from position 0. And what we get is, and we take an input we're taking an input 33 and we're writing it to position 0. And actually we did that, that's correct. No, we didn't do it correctly. We actually should have written 3 there. So position 0 should be the actual position 0. What are the modes for this one? The star means that it's positional mode, basically. And I'm not sure how it is working. So we're going to debug like this. Let's put a breakpoint here at the input program. Run it. And then we're going to continue until we hit that part. And when we run the program and extract the parameters, maybe it's in the way I'm doing get parameters at input. I guess that's where it's going wrong. So I have input parsing somewhere here. Opt in, where is it? Here. So I'm getting the parameters. Okay, that seems correct though. It seems correct. Okay. Alright, for output parameters we should basically deal with it as if it's an immediate mode and not a positional mode. And the positional mode was the default one. So it means I'm actually doing my override in the wrong way around. So if we're in output mode and we are doing position, then basically we should use the immediate mode logic. That's what should work. Yeah, cool. I like how reasoning can solve problems. And this one also works. And now do we have a solution? It's still 203. You're still saying that 203 is wrong. Day 7 also has some tests, so let's run that one. So it seems like this particular case actually was not being used in the other days so far, even though well, okay, I guess the only new thing here is the relative thing. So maybe it was really not relevant so far. Okay, so we still get 203 is not working. And we did verify that the right 2 digits are... Hold on, this is the wrong day. The right 2 digits are the opcode. And that means that 203 means opcode 3. It means that that is actually an input and that probably we're doing it wrong. But we can hold every time we have an input and see what's going on. So we have an input here and let's wait at that position and run only the solutions. Yeah, we're going to run only the solutions right here. And running it. I'm pretty sure that once I'm done with part 1, I only need to change the program input to something else and show the output. And hopefully that will work right away. Let's run it in debug mode. Okay, so there we are, we're reading input and it says instruction 203 right here. So that means that we are actually in the position where it was going wrong. And 203 means that we're going to read the parameters right here, get parameters, and I'm adding a breakpoint. And we have how many modes? We have a list of one mode, and it's mode 0. Mode 0 means positional mode, right? Okay. And it should be an output mode. The output modes that we have, or the output parameters, is a list with 0, and our position index is 0. So is output should be true, and it is. And now we have the following check, and it doesn't actually pass. So mode is now 2. Hold on a second. Mode is now relative. Okay. Okay, I think I just misread. It was already relative from the beginning. And we have mode 2. And here we're handling how it works relatively. And when we're reading relatively, we're going to first get the relative value. But for an output, we should actually return that value and not dereference it. Oh my god. So that's how it works. So we have a position. So relative output and input are really different. So I'm going to return position if we're dealing with output, right? And does that also happen for the case of positional mode? I'm not sure. Well, we don't use that one. We're always going to replace positional with immediate. I do find that I'm not really breaking down my cases in the right way. Yeah. I think I'm not doing it in the right way, but we don't have an immediate mode. We do have a positional mode, but it's replaced by immediate mode. Ugly, but I think this is going to work. To do split up cases differently. This is probably one of those examples where you make the wrong abstractions and they're haunting you forever. So part 1, cannot unpack non-iterable int object. Okay, why is that? Is it because I changed this and I'm changing it? Let's see. I think I probably only need to do this for the case of int and not for other instructions that write. I'm not entirely sure. So I'm adding a break. I have my breakpoint still. And where are we now? We're at get parameters, and the first instruction pointer is 0. Okay, what are we doing exactly? We are now, I'm not sure which instruction we're handling at the moment. I think let's load the input and have a look. Input for day 9. Okay. Okay, well, no, that's not possible to read. Never mind. I don't want to break right away. I want to break from the moment that we actually are reading input. That's right here. So I'm going to remove this breakpoint from the get parameters. Closing up a little bit. And running it until we're here. And then we're going to jump, jump, jump. And so our instruction looked like this. So in our console we should have, in our debugger we should have our instruction 203. It means upcode 3, and the output position. Oh, that's probably the previous one. Let's ignore it. And that means that there's also going to be a value right after, excuse me. And okay, the value right after, what is that? Let's look in the console. So we have an input somewhere here. That's this one. And I'm printing it as a dash. That means immediate mode. But we have a new mode now. So instead of writing star for mode 0 and otherwise the dash, we also are going to add a case for the relative mode. I'm not sure if you can do a triple ternary in Python. I guess you can't. So in that case, I'm going to do it a bit differently. So we have a star, a dash, and let's say relative mode is a wiggle, like that. So we run it again, and we should get now a wiggle in there somewhere. In is here, and that's the wiggle. And so it says it's going to take the relative base and write the output to relative base plus 0. And relative base right now is 1000. Okay, so it's going to write to position 1000 if we're doing it right. Let's see. We're going to jump into this one. Why does that not work? Step into my code. I just did that and we didn't actually step into anything. Oh, maybe I have to press it again. Okay. So the output should be 1000 in the end, right? So we are dealing with an output and we do have a relative mode, right? Mode 2. So we're going to go there. And then we have the relative value, and that is 0, we know that. And that works. Then we need to calculate the position, the output position. Random thought, immediate mode makes some kind of sense for input. It would just override the destination parameter with the input value. That's what I was thinking also. It's kind of like a setter, just like write a value to a place. So I'm not sure why we're making it so hard to avoid it. Maybe in day 10 or 11 we're going to have to support immediate mode for inputs also. Who knows? Okay, so now we have 1000 and I'm returning 1000. Okay, so that means if I jump next, here we have 1000. And why am I jumping straight out of the execution loop? Is that because I actually have an exception or something? So we have a loop. Here we're doing a write into the output position. Maybe it didn't crash, maybe it just worked actually. So let's go again to the input. It was here, and looks like we're just going to continue. No, we're getting an error, and not so clear why. Okay, cannot unpack non-iterable int object. So we have output positions for a certain opcode, and the opcode that we're reading is 0 most likely. That's what I think. So let's actually check for opcodes that are either valid or invalid. So we have, right. I'm not sure why we actually end up here. So we're still in input, okay. We're doing an input and then we get an invalid opcode question. Invalid opcode exception. Cannot unpack non-iterable int object. What does that mean? Oh, right, of course. Oh, it's such a simple bug. We are supposed to return tuples, but I'm only returning the position. And we're supposed to return tuples because we always output multiple things. And of course I could also just not unpack it, but just to be consistent, I'm doing it this way. Oh wow. And now it says not enough values to unpack. And that's in the case of... Oh, I see. So actually we should not just return, we should just define the parameter as being the position, and otherwise we're going to read it like that. Yeah, I have a good feeling about this. is running for a very long time. And we have a code, a single code. There we go. So we have it finally. That took quite a bit of time. It's 7:45 here locally in Belgium. Thanks for hanging out for so long. I still have part 2 to do. And what I need to do is append only, to pass it only value 2. That's it. Thank you, Crespel. I'm happy to solve it finally. But I must say it was kind of a chill way to do it, but it was almost 2 hours. I think it's a bit longer than I hoped to do these puzzles in. The correct answer is like this. We're going to run it again with input 2 and print the output. Better late than never, that's true. Well, there was one day, and it was, I think, day 5, and I couldn't actually finish it. And I had to finish it later during the day without streaming. Part 2, come on. It's a bit longer. Oh god. Maybe I should disable debug for this one. Let's actually do that. Oh, you're also done. Oh, well done. No, sorry, misread that. You'll be struggling for a while, I think, but you did solve the other puzzles so far, right? There we go. So you can build on top of what you had, and you are going not to make the same mistakes as I did. I hope. I know. That's the right answer, so that was it. Cool. Yeah. It's getting a bit late. I'm sorry, I'm not going to have time to actually do any code reviews today. I might be able to do it tomorrow before Advent of Code starts, very quickly. That depends. If you're going to have time to join in a little bit earlier than normal, like 20 minutes or so, then we can do a code review before the next puzzle is released. One day you will be. We all are trying to be wizards. That's our mission as programmer. I do feel like a wizard as a programmer though. It's like so magical, I think, to build something that doesn't exist and you make it and it actually is doing stuff that you wanted. I think it's very magical. Right. Unversioned files, that's some code sharing files. Part 2, part 1 and 2. Finished. Cool. Yeah, I actually really have to leave. It would be nice if I could catch my train in about 30 minutes. That means I have 15 minutes left to do a little bit of breakfast and get myself prepared. Oh, let me just restore this. So for today, no code reviews. I hope to see you again tomorrow, and you're going to head to wizard school yourself, and it will have to wait for later. Yeah. Okay. Thanks, Zrankovic, Crespel, and Fuzzy, and Sir Chowtek for joining today. And for those who are watching but are not on the leaderboard yet, I will just add here again the join code. Just go to adventofcode.com and paste your join code in there, and you'll be on this leaderboard. If you give me a direct message with your Twitch name and your Advent of Code name, then I'll make sure that you show up on the stream correctly. Have fun again for tomorrow's puzzle if I don't see you before the puzzle starts. And so I'm going to try to stream at 11:40 New York time or 6:40 Brussels time. Have a good day, have a good night. See you again.